All right, get ready, because we're driving into something today that sounds straight out of science fiction. Time crystals.
Time crystal.
And no, not like, like some mystical new age thing. We're talking about matter that never stops moving,
Uh-huh.
even at its lowest energy state. It's kind of mind-boggling, isn't it?
It really is. It definitely, it challenges how we typically think about how things work in the world. I mean, you probably think of crystals as being those static, unchanging structures.
Yeah.
But time crystals are, well, they flip that idea on its head. They bring in this whole other concept of movement at the atomic level, even in their ground state.
And, from what I was looking at in the cocktail party chemistry
Yeah.
episode, it's not just any movement. It's like this constant energy-free dance
Yeah.
that just seems to, completely defy the laws of physics as we know them.
Right.
They actually had 5 key points about time crystals that I think are worth, revisiting.
Okay.
First, these crystals are constantly in motion, and they exist in their lowest energy state,
Right.
which is already kind of like...
Right.
And this motion, get this, doesn't require any external input.
Yeah.
And they have this crazy potential for things like quantum computing.
Uh-huh.
And lastly, they totally challenge how we think about thermodynamics.
Yeah, you've got it. That's a really good summary of it. Those 5 points really do really highlight the paradox of time crystals.
Yeah.
It's almost like if you discovered a waterfall that was flowing uphill.
Yeah.
It's fascinating, but also confusing and potentially groundbreaking all at the same time.
Yeah, exactly. So let's maybe try to unpack this a little bit.
Okay.
When we talk about them being in constant motion, what does that actually mean? It's not like they're, running around the room.
Right. No, it's
Ooh.
definitely more subtle than that. The motion that we're talking about is happening at the atomic level.
Okay.
So the atoms within the time crystal, they're constantly shifting
Yeah.
and oscillating, but it's in this predictable pattern, almost like a choreographed dance that never ends.
Okay, so imagine this microscopic dance party just happening 24/7
Yeah.
inside this crystal.
Uh-huh.
But here's where I get tripped up.
Go.
If all these atoms are constantly moving, shouldn't that require energy?
Right.
And if it doesn't, how is that even possible?
Yeah.
It would be like having a car that runs forever without needing any gas.
Yeah, that's a great point. And that is really the core of the time crystal puzzle.
Yeah.
And this is where things get really interesting. The answer to this puzzle actually lies in quantum mechanics.
Oh, okay.
A world where the rules of classical physics, well, they don't always apply. In quantum mechanics, particles can exist in multiple states at the same time.
Yeah.
And this allows for perpetual motion without needing that constant energy input. It's kind of like, well, imagine borrowing energy from the universe itself.
Okay, I'm trying to wrap my head around this borrowing energy idea. But can we back up for a second? Because the episode also mentioned that time crystals exist in their lowest energy state.
Yes.
Isn't that a contradiction? I thought things in their lowest energy state were supposed to be, well, still.
That's a really great question. And it really highlights why time crystals are so revolutionary.
Yeah.
They completely challenge our fundamental understanding of thermodynamics,
Mhm.
which basically says that systems in their lowest energy state, they should be static,
Okay.
in equilibrium. But time crystals, they throw a wrench in that whole idea. They
Yeah.
can't lose any more energy, but they're still moving perpetually.
So it's like they're breaking the rules,
Wrench.
but still playing by them?
Exactly.
That's wild.
It is.
So how do they actually achieve this? What's the, secret ingredient?
Well, the secret ingredient, if you will, is something called time translation symmetry breaking,
Oh, wow. Okay.
which sounds really complicated, but it's actually pretty intuitive once you sort of break it down.
Okay.
So imagine a snowflake, a perfectly symmetrical snowflake, and you can rotate it a
Oh,
certain number of degrees, and it'll still look exactly the same.
okay.
So that's what we call spatial symmetry.
Right.
But time translation symmetry, it's similar, but it applies to time instead of space.
Okay.
It means the system looks the same at any point in time.
So I'm picturing a video on pause.
Yeah,
No
exactly.
matter when you hit play, it always starts at that same still frame.
Exactly. But time crystals, they break that time symmetry.
Okay.
Their structure doesn't repeat every single point in time,
Uh-huh.
only at specific intervals. It's like if you could only hit play on that paused video every 10 seconds,
Okay.
and it would reveal a repeating pattern.
Okay.
So that break in symmetry, plus all the weirdness of quantum mechanics.
Yeah.
That's what allows the crystal to exist in the state of perpetual motion without needing that constant energy input.
So they're not actually violating the laws of physics. They're
Right.
just like bending them?
They're bending them in a way that we haven't seen before.
Right.
And that's exactly why physicists are so excited about this.
Yeah.
They're forcing us to rethink everything we thought we knew about the universe and explore new frontiers in quantum mechanics and thermodynamics.
Yeah.
It's very cool stuff.
Yeah. It's like we found this whole new rule book for how matter can actually behave, and we're only just beginning to understand it.
Yeah, and this isn't just like theoretical, right?
Right.
I remember the episode talked about time crystals actually being made in a lab,
Yeah.
which is kind of hard to believe.
Yeah.
That something that seems impossible is possible.
It is mind-boggling, but it's true. Time crystals have gone from theory to reality.
Wow.
Back in 2016, there were 2 separate research groups
Okay.
that were able to create time crystals in a lab setting.
Wow.
So that confirmed that they do actually exist.
Okay, so color me impressed.
Uh-huh.
But how do you even go about creating something like that?
Right. It's not like you can just mix a few chemicals together.
Right. No, it's definitely not a DIY project.
Yeah.
These experiments were incredibly complex. They involved lasers and ultra-cold atoms
Okay.
and these precisely controlled magnetic fields. So imagine trying to choreograph a dance at the atomic level.
Oh, wow.
That's essentially what these researchers did.
Wow. Okay. So these lab-created time crystals.
Yeah.
Are they like exactly the same as what the theories predicted?
Yeah.
Or is there still stuff to like figure out?
Well, they do line up really well with what the theories predicted, but there are still a lot of unknowns.
Okay.
Right now, research is really focusing on fully figuring out all of the properties of time crystals and understanding their limitations and, figuring out how we can control their behavior in a more precise way. It's kind of like when you have a brand new gadget
Yeah.
and you're just trying to figure out all the buttons and settings and what they do.
Okay. Speaking of gadgets,
Yeah.
let's talk about like what we could use time crystals for. Right. The episode hinted at some pretty amazing possibilities,
Right.
especially when it comes to quantum computing.
Yes.
Quantum computing is like a big buzzword these days.
Right.
Can you remind me what makes it so special?
Yeah. So think of it this way. The computers that we use now, those are like bicycles.
Okay.
Quantum computers, those are like supersonic jets.
Oh, wow.
They operate on completely different principles. They actually leverage quantum mechanics
Uh-huh.
to perform calculations in ways that are impossible for classical computers.
Okay.
So, for example, quantum computers can exist in multiple states at the same time,
Yeah.
which means that they can explore tons of possibilities all at once. And that leads to, like, exponential speedups for certain types of problems.
So problems that would take our current computers maybe centuries to solve,
Right.
a quantum computer could do in minutes?
Exactly.
Yeah.
We're talking about potentially revolutionizing fields like, medicine and materials science, AI, the
Yeah.
list goes on. But
Yeah.
there is a catch. Quantum computers are really hard to build,
Okay.
and they're even harder to keep stable. And that is where time crystals come in.
Uh-huh. Knew there had to be a connection.
Right.
So how do time crystals help us overcome those hurdles?
Oh, okay. So the building blocks of quantum computers, they're called qubits.
Okay.
And they are super fragile. They are prone to errors from even the tiniest disturbances in the environment. Think of them like delicate butterflies
Okay.
that need a perfectly calm environment to fly.
All right.
But time crystals, they're inherently stable.
Yeah.
They're resistant to those kinds of disruptions.
Mm-hmm.
And they could potentially be used to create much more robust qubits that won't make as many errors.
Okay.
So imagine quantum computers that don't constantly crash or lose information. That's what time crystals could offer us.
Wow, that would be a huge deal.
It would be.
Stable qubits would essentially unlock the potential of quantum computing.
Exactly.
Okay.
Yeah.
I have to ask, though, are there any other potential uses for these time crystals beyond quantum computing?
Absolutely. While quantum computing is definitely a big driver behind time crystal research,
Uh-huh.
scientists are looking at a whole bunch of other possibilities.
Okay.
For example, imagine timekeeping devices that are so precise.
Yeah.
They could actually redefine how we understand navigation and time itself. We're talking about atomic clocks on steroids.
That's incredible. And if we can measure time more accurately, who knows what kinds of scientific breakthroughs that could lead to?
Exactly. And the potential doesn't stop there. Researchers are also looking into how time crystals could be used for sensors.
Ooh.
Ultrasensitive sensors that can pick up tiny changes in the environment, which could be used for medical diagnostics, environmental monitoring, even exploring dark matter.
So it seems like the more we learn about these time crystals, the more their potential uses just expand.
It really does seem that way.
Yeah. But I think it's easy to lose sight of, like, the big picture here. Why should someone who's not a physicist or, like, a computer scientist, why should they care about this discovery? What's, like, the takeaway for, the average person?
That's a great question. And I think what it boils down to is this. Time crystals are a reminder that our universe is still full of surprises. There's so much we don't know.
Yeah.
And things that seem impossible can become possible
Yeah.
with a bit of curiosity and a lot of scientific work.
Yeah.
It's about pushing the boundaries of human knowledge
Uh-huh.
and expanding our understanding of the world around us.
Yeah, it really is. And, I have to admit, when we first started talking about this,
Yeah.
my brain kind of went to, like, sci-fi land.
Yeah.
Matter that never stops moving.
Right.
Sounds like time travel or something.
I can definitely see why you would think that.
Yeah.
The idea of perpetual motion, it's always fascinated people.
Yeah.
And time crystals kind of embody that in a way we didn't think was possible.
Yeah.
But what's really interesting is this isn't just like a theory.
Right.
It could actually change how we think about time itself.
Okay, now you've really got me curious.
Uh-huh.
How could it change how we understand time? I always thought time was a constant,
Right.
like a fundamental thing in the universe
Right.
that can't be messed with.
That's what we always thought, right?
Yeah.
Time moves forward,
Uh,
never backward, always at the same pace.
yeah.
But time crystals, they might actually challenge that
Really?
with their special properties.
Yeah.
Like some physicists are saying that because time crystals are cyclical
Okay.
and they can repeat patterns over time,
Mm-hmm.
that could actually give us some clues about time as a dimension.
Okay.
It might even hint that there are multiple timelines or alternate realities.
Whoa. Hold on a second.
Mm-hmm.
Are you saying time crystals could be like a window into a multiverse?
Maybe. It's a possibility.
You're blowing my mind here.
It's pretty wild stuff.
Okay, even if we forget about multiverses and stuff,
Yeah.
the implications for, like, physics are huge.
They are. Time crystals are forcing us to look back at some of the most basic laws of physics, particularly the laws of thermodynamics.
Okay.
For a long time, we thought that systems in the universe,
Wow.
they tend to move towards equilibrium, towards a resting state,
Okay.
where energy is evenly spread out.
Right.
But time crystals, they totally changed that idea.
Yeah.
They show us that perpetual motion, at least on a quantum level, is possible.
Okay.
And that systems can actually stay organized and complex,
Yeah.
even in their lowest energy state.
So it's not just about new technology.
Right.
It's about a change in how we see the universe.
Exact.
And the laws that, like, control it.
Exactly. Time crystals are a big shift. They
Okay.
remind us that we're still just starting to understand what reality really is, and who knows what other, seemingly impossible things are out there, just waiting to be discovered.
It's exciting and, a little bit scary.
It is.
to think we've got it all figured out.
Uh-huh.
And then something like this comes along and changes everything.
Exactly. And that is the beauty of science.
Yeah.
It's always about discovery,
Uh-huh.
challenging what we think we know,
Yeah.
and pushing the limits of what we know as humans.
Yeah.
Time crystals are a great example of that. They remind us that the universe is still full of mysteries waiting to be solved.
So as we wrap up our deep dive into this,
Yeah.
crazy worlds of time crystals,
Yeah.
what's the one thing you want our listeners to remember?
I would say be open-minded,
Okay.
embrace the unknown,
Yeah.
and never stop asking, what if?
I love that.
Time crystals are proof that even the craziest ideas can be real, and that the journey of discovery, that can be more rewarding than the destination itself.
To our listener, keep asking those questions.
Yeah.
Keep exploring.
Uh-huh.
And who knows? Maybe you'll be the one to make the next big discovery.
That would be awesome.
That changes how we see the universe.
Exactly.
Until next time, happy exploring.